Hi students, now I am going to explain about determination of H parameters from transistor characteristics and H parameters analysis for transistor configurations. Let us see now how to determine the H parameters from the transistor characteristics graphs. So as we know that the basic fundamental formula for a H parameter which are called V1 and I2 dependent variables. This V1 and I2 which is equal to V1 is equal to H11 I1 plus H12 V2. I2 is equal to H21 I1 plus H22 V2. So these two equations are called the H parameter equations. Now, how to determine these H parameters like H11, H12, H21 and H22. When we come to transistor, these H parameters can be applied to transistor configurations, whether it is CE, CB, CC. For example, when we see that the transistor is in common emitter configuration, then the equation at this Kirchhoff voltage law and Kirchhoff current law are simply H parameter model equations can be applied to common emitter configuration. Then that equation V1 becomes VBE, because when we see that common emitter configuration, emitter is connected to ground and base terminal is connected to input and the collector terminal is connected to output. When it is connected to input, base is connected to input current is IB, input voltage VBE. Okay, when it is output current, it is a collector terminal, so output current is IC, output voltage is VCE. So here it is V1 represents port 1 voltage, so input voltage, we can replace this V1 with the VBE, input voltage V base to with respect to emitter VBE, and then VBE is equal to H11 means input impedance, so we can represent HI, E suffix E represents the common emitter configuration. Likewise, we can rewrite this V1 and I2 equations in terms of common emitter configuration H parameter model. Then VBE is equal to HIE IB plus HRE VCE. HRE VCE. And IC is equal to HFE IB plus HOE VCE. Now, how to determine this H parameters like HIE, HRE, HFE, HOE? So we will see these parameters can also be found from the graphical analysis. Let us consider that a graphical representation of input characteristic of C configuration, and this input characteristics, it is a common emitter configuration, is a graph, input characteristic graph between input current IB, input voltage VBE, and by keeping output voltage constant VCE, output voltage between collector and emitter. So here the graph is a IB in microampere, VBE in volts, and by keeping output voltage constant 2 volts. We know that why these graphs for VC is equal to volts, and then VC increased to 2 volt to 6 volt, and then 10 volts. Due to this base width modulation, the graphs move right side. Now find out what is the HIE from the graphical analysis. Generally, HIE is nothing but input impedance in common emitter configuration. So which is defined as it is the ratio of change in input voltage to the change in input current. Here input voltage is VBE, so VBE delta VBE by delta IB by keeping VC constant. Now, with what does it mean by keeping VC constant and the ratio of input voltage VBE by delta IB, which means consider a constant graph. For example, one graph. If you take any one graph, so I am considering, for example, if I am considering any one graph, it will be treated as, for example, if you take this VC is equal to 10 volts graph. So by keeping VC is equal to 10 volts, by keeping VC is equal to 10 volts, and then what is changing in VBE, input voltage, and changing IB. So when we take the constant VCA, this is take the one graph and a corresponding graph. If you take any point, whether it is, you can take point on the graph and then take a tangent line passing through the graph or that Q point, then the change in x-axis corresponding change in y-axis. So this we can find out the change in slope in x-axis and slope in y-axis. So corresponding slope, for example, if you take corresponding slope is this one, a change in voltage. This is the change in voltage. Corresponding change in voltage nothing but delta VBE, and the corresponding current is nothing but delta IC in the particular graph. VC is equal to 10 volts. So in this constant VC 10 volt graph, on this graph, the change in voltage which represents the VBE1, VBE2. This is VBE2, VBE1. Corresponding current VBE2 having approximately 70 microampere, and the corresponding current it is 48 likewise. So the ratio of changing voltage VB, input voltage delta VBE divided by changing current IB. So you will get that the HIE will get in some ohms or some kilo ohms. So we can measure here that HIE approximately he can calculate. It is the ratio of change in input voltage VBE. Suppose if you consider this voltage, the voltage, for example, this is the voltage we can represent here. (1.0 minus 0.8 divided by 70 minus 45 into 10 to the power of minus 6. So we can take 0.8 divided by, and this 25 into 10 to the power positive 6, so that we can calculate it in the value is represented in some kilo ohms. The units for HIE which is represented in kilo ohms or ohms, so that we can determine the input impedance from the input characteristics. Similarly, same characteristics graph, same input characteristics, we can also find out the reverse voltage gain. So in this reverse voltage gain, we can consider input current is constant. How can we measure by considering the input current constant? Let us take, if you consider input current constant, IB, I am considering some constant input current. For example, same line, I am drawing the same line 45. If I am considering the 45, so take the 45 microampere current line. This is the line represents the 45 microampere line. So this is 45 microampere current line in from input characteristics. Now, what is the HRA? HRA represents, so reverse voltage gain in common emitter configuration. Reverse voltage gain, which is the we can find out by keeping input current IB constant, and then it is the ratio of input voltage VBE divided by output voltage VCE. Change in VBE, change in input voltage divided by change in output voltage. So by considering this straight line, constant line, so what is the change in input voltage and what is change in corresponding output voltage? So when we change the output voltage from 2 volts to 6 volts on the constant line, so the cross section point for the VC 2 volt graph and VC is equal to 6 volt graph. These are the change in voltage, output change in voltage on the constant IB is equal to 45 microampere line. So and its corresponding voltage, so its corresponding voltage in input, so we can represent some 0.6, 0.7 likewise. So when we calculate this HRE reverse voltage gain is equal to change in voltage 0.8, for example 0.8 minus 0.7 divided by corresponding voltage 6 minus 2 volts. So when we consider this one, so input is also volts, output is also volts, so no units for the reverse voltage gain. 0.1 divided by 4. So when 0.1 divided by 4, so it will be represented some a constant value, some volts or like some constant values we get. So reverse voltage gain, so 0.1 divided by 4, and here it is we can represent it with 1 by 40. So we can find out the values, and then this value is a reverse voltage gain. We can calculate input impedance and the reverse voltage gain from this input characteristics. Similarly, the forward current gain and the output admittance can be calculated from output characteristics. This is the output characteristics for common emitter configuration. So if you see that what is HFE? HFE, according to the definition of H parameters, HFE is the forward, F represents forward current gain and in common emitter configuration. HF nothing but forward current gain and HFE nothing but forward current gain in common emitter configuration. Common current gain in common emitter configuration calculated from output characteristics. Output characteristics is the graph between output current and output voltage VCE. So when we take by keeping input current constant from 20, 40, 60, 80, 100 and so on. So it is the ratio of change in output current by change in input current by keeping output voltage constant. How can we get by keeping output voltage constant in the characteristic graph? So if you take a line by keeping output voltage constant, for example 6 volts. So if you take a line on this 6 volt, if you take a straight line on the 6 volts, then what is the change in current and what is the change in input current and what is change in output current? Output current corresponding current, which is nothing but 4 and 6. So this is the change in collector current and corresponding change in base current. So HFE is equal to at a constant volt 6 volts VCE, change in IC current nothing but 6 minus 4 into 10 to the power of minus 3 because it is IC current divided by IB current 60 minus 40 into 10 power minus 6. So that we will get some 2 into 10 power minus 3 divided by 20 into 10 power minus 6. Some minus 3 minus 6 cancel. You will get the value is 20 divided by means 1 by 10. Then 10 and this one cancel 1 by 10 power minus 2. You can get the 100 approximately HFE. So in DC analysis, this HFE can also be called it as beta current gain in common emitter configuration. So the range of beta is always 50, some 50 to 200. So this value, it becomes in this case from this characteristic graphically a beta or HFE is equal to 100. So that the current gain HFE is equal to 100 means IC is equal to beta IB, for example. So when we find out the current, when beta substitute in 100 by multiplying a microampere, you will get milliampere current, amplified current in the amplifier circuit. So that you will get here beta HFE is equal to 100. HFE is equal to 100. So this can be determined from this output characteristics. Now we will see some other parameter which is called HOE. HOE nothing but output admittance. Output admittance in H parameter model. So this output admittance can be calculated. This output admittance can be calculated by keeping IB is equal to constant. This IB constant means by considering a constant IB curve, this characteristic graph. And then change in IC and change in VCE. So by keep constant of IB means the considered IB is equal to 60 microampere curve. So upon this curve, when we take the 2 points in the x-axis and 2 points in the y-axis, that is simple representation of change in VBE. Change in collector to VCE and corresponding IC current. It is actually a small variation. So the slope is very small. So that's why you will get HOE is equal to what is IC, which is nothing but at a 60 microampere you will get 6 minus 5.8 or 6.1, 5.8 divided by 6 minus 4 into 6 minus 4 volts. It is in milliampere, 10 power minus 3. So 0.2 divided by 2 into 10 power minus 3. So you will get 0.1 10 power minus 3, nothing but 1 into 10 power minus 4 approximately. So you will get this output admittance, we can get 1 into 10 to the power minus 4 mhos. So the units for admittance is reciprocal of ohms. So it is represented with mhos. So in this way we can calculate it. So if you change the characteristic graph, sometimes in common base configuration, so you will get common base exactly straight common emitter, somewhat slope common collector, somewhat slope, so that you will get some different values of output admittance. So here likewise we can determine the H parameter values in common emitter configuration. Similarly, same H parameter values can be calculated from input and output characteristics of different configurations, common base and common collector. So in this case, the parameter values, the representation of parameter values may be a small change in the subscript. HIB, HRE, HRB, and HFB, HOB. So in this common base configuration, for example, it is common collector configuration, we can calculate from the characteristic graph HIC, HRC, HFR, HFC, and HOC. So likewise, we can calculate these parameters from the input and output characteristics of common base and a common collector configuration. Now we will move to the determine the hybrid equivalent circuit from the general amplifier. Now we can see a simple transistor amplifier circuit represented in two-port network model. A transistor connected in any among those configurations. That configuration can be represented with the block diagram. A transistor connected in a general configuration, and then which is when we connecting to the resistor, a source resistor, by connecting source voltage and its internal resistance source. and by connecting load resistor RL, so that we can make the transistor as an amplifier. So this is general amplifier circuit, which consists of source voltage and load resistor, and source voltage with internal resistance, source resistance Rs, and a load resistor RL. By considering this is a two-port network, the direction of current, input and output current tend towards to the port, and the voltage between input and output is V1 and V2. When we connecting this source resistor and load resistor, the current flow in the load resistor direction is opposite to the two-port network current, output current I2. So IL is equal to here I minus I2. So what is corresponding equivalent H parameter model or a hybrid equivalent circuit? In previous lecture, I explained how to draw the hybrid model for a transistor, only transistor connected in either common emitter, common base, or common collector. If you see here, so the input in the transistor hybrid model having two circuits. One is the input Kirchhoff voltage law circuit and output Kirchhoff current law circuit. The input Kirchhoff voltage law circuit consists of input impedance and some voltage source, dependent voltage source, and output side one current source in parallel with the admittance, in parallel with the resistor. So this is only for transistor connected in common configuration. And when we connecting the extra this RS resistor and voltage source here, and a load resistor across port 2. Port 1 connected with this source voltage, and port 2 connected with the load resistor, so that it will become a equivalent circuit for a generalized amplifier. Then when we connected particular configuration, common emitter or common base or common collector, that particular common terminal connected to ground, and the remaining two terms are connected to input and output terminals respectively. So when we apply this kind of generalized transistor amplifier, what will be the H parameter equations, the equivalent H parameter model equations? That H parameter equations are V1 and I2, which is equal to Hi input impedance Hi I1 plus HR V2, and I2 is equal to H of forward current gain I1 and reverse admittance, output admittance H0 V2. So this is the generalized H parameter equations for this transistor amplifier. When we connected this amplifier in different configurations, that parameters H1 and this H1, Hi, HR, HF and H0 represented with extra term. If it is connected in common emitter, it is represented with the HIE, HRE, HFE, HOE. So when we connected in common base, it is represented with the HIB, HRB, HFB, HOB. So when we connected this one in common collector, HIC, HRC and HFC, HOC. Likewise, we can use this subscript in different configurations. Now let us see the expression for transistor amplifier. Input and output resistance, voltage gain and current gain may be obtained from the relation of this V1 and I2. So the main purpose of this H parameter model is to calculate the parameters of transistor, which are called input impedance and output impedance, or input resistor, output resistance, and voltage gain and current gain. These four parameters which will useful to analyze that particular transistor amplifier is useful for amplifier or impedance matching circuit, or one particular circuit make use of that particular circuit at the input stage or intermediate stage or output stage. So by analyzing this amplifier, we can make use of that circuit used in different applications. So here, how to determine the parameters like this input impedance and output impedance voltage gain and current gains for a transistor amplifier. So when we see this diagram, so it is connected to the load resistor RL. So when it is connected to the load resistor RL, then what is the load current? The current flow in the load resistor IL is equal to, so the voltage drop across the load resistor, which is equal to voltage drop across the output terminal. Voltage is whatever the voltage across the output terminal of the H parameter model. When we connecting a parallel in parallel with the load resistor, the same voltage appear across the load. When voltage is across the load, but direction of the current flow is that V2 is equal to I into RL, IL into RL. When we represented in terms of I2, that H parameter transistor model current, I is equal to IL is equal to minus I2 into RL. So what is the voltage across V2 is nothing but minus I2 into RL. Now let us find out parameters one by one. First parameter is, for example, current gain. So current gain represented with capital A with a small I, suffix I. So the current gain in a transistor amplifier. How to determine the current gain? A generalized current gain from the transistor amplifier represented in H parameter equivalent circuit. So it is the ratio of output current to the input current. What is output current in this diagram? This is the amplifier output. If we are not connecting a complete amplifier, it is the current is output current is two-port network current is I2. But when we are connecting load and source, so what is the output current is IL. So here at output current is IL, ratio of output current divided by ratio of input current I1. So this I1, IL by I1. As we know that this load current direction is opposite to the port current, so we can represent it IL is equal to minus I2. So I is equal to minus I2 by I1. It is the formula. So it is defined as ratio of output current to the input current, which is equal to minus I2 by I1. So this this definition we can apply to the analysis. Now substituting the value of V2 is equal to minus I2 into RL, minus I2 RL current voltage drop across the load resistor. This V2 substitute in the two-port network equation, second equation. What is two-port network second equation? Says that I2 is equal to HF Phi1 plus H0 V2. So consider we want to determine the current gain. That current gain in terms of two parameters which are called I2 and I1. So what is the idea behind to we can apply which equation, whether it is equation V1 or whether it is equation I2. So by seeing this equation, in order to find out current gain AI, which is related with the I2 and I1. So in this current second equation, I2 is equal to HF I1 plus H0 V2. So almost there is a one I2 term and I1 terms. So when we replace this V2 term in terms of I1, in terms of I2, then we can easily extract that ratio of I2 by I1 so that we can find out the current gain. So consider that second equation, that two-port network second equation, which is equal to I2 is equal to HF I1 plus H0 V2. So in order to find out current gain, so what is this unrelated term V2? When we written in terms of either I1 or I2, we can entire equation represented in the ratio of I2 by I1. So already we have a formula that V2 voltage, what is output voltage? V2 is nothing but in terms of minus I2 into RL. When we substitute that minus I2 into RL in the equation, this I2 equation, so replace this V2, which is equal to minus I2 into RL. HF I1 plus H0 minus I2 into RL, we can return as HF I1 minus H0 I2 RL. So here I2 terms take one side and I1 terms takes other side. I2 plus H0 I2 RL is equal to HF into I1. And separate this I2 term so that I2 of is equal to I2 of 1 plus H0 RL is equal to HF I1. Now left side I2 term is there, right side I1 term is there. So ratio of I2 by I1 will get Hf by this term gets denominator on right side, then Hf by 1 plus H0 RL. This is I2 by I1 ratio. But what is the definition of current gain? AI is equal to minus I2 by I1. When we put minus term for this expression, what we got? So then we get minus. Then what is I2 by I1 is nothing but this Hf by 1 plus H0 RL. So that is the formula for current gain in H parameter equivalent circuit for an amplifier. So if you consider any amplifier, what is the current gain AI is nothing but it is the ratio of minus Hf forward current gain of a model, H parameter model, divided by 1 plus. So H0, here it is H0 output admittance into small RL, nothing but load resistor. So minus Hf by 1 plus H0 RL. That is called current gain formula determined from the amplifier, transistor amplifier, by using H parameter model. And second one is input resistance. This is the one of the important parameter. So input resistance generally measure at input side. It is the ratio of input voltage by input current. The resistance which we see looking into the amplifier input terminals 1 and 1 dash is called amplifier input resistance. When we look into the input port, so that the input impedance is nothing but it is the ratio of input voltage V1 and input current I1. So it is the ratio of input voltage V1 and input current I1. The voltage V1 and I1 formulas are included in the equation 1. For example, it is equation 1. Here it is term V1 and I1 term. So only when we replace this V2 terms in terms of V1 or I1, then we can get the input impedance from the equation 1, H parameter equation 1. So in order to obtain the input resistance, consider the equation 1 or consider the fundamental equation of H parameter model. V1 is equal to H1 I1 plus H1 HI1 HR V2. So we have a formula for V2. V2 is equal to I2 into RL. So in order to get this entire equation in terms of V1 and I1, so we can take this V2 replace with the formula minus I2 into RL. So V1 is equal to HY I1 minus HR I2 RL. Again here V1 term is there, I1 term is there, and I2 term is there. But we want only V1 and I1 terms. How can we get V1 I1? By removing these I2 terms. When we dividing this equation, for example, this is the equation. When we dividing this equation by I1 on both sides, when we dividing this equation on both sides, so ratio of V1 by I1 is nothing but input resistance. So by considering V1 by I1 and right side also divided by I1, so V1 by I1 is equal to H1 I1 minus HR I2 RL by I1. So what is the purpose to divide this I1? So here the idea behind this division of this I1 is, when we consider this I2 by I1, already we have calculated current gain first. So just to replace this I2 by I1 with the current gain, so that we have already V1 by I1 ratio formula and then I1 and current gain, so that we can relate it with this entire equation in terms of input resistance. So now when we consider on the left side, the ratio of V1 by I1 is nothing but the input resistance is equal to H1 I1 divided by I1, nothing but I1 cancel, will get HI minus HR I2 by I1. Take in bracket so that we can define that I2 by I1 as a current gain into RL. So Ri is equal to V1 by I1 is nothing but Ri is equal to Hi minus HR into the equation I2 by ratio of I2 by I1 is represented as current gain. Already we calculated previous slide. So AI into RL. So this AI AI actually AI is equal to minus I2 by I1. So but here I2 by I1, we can I2 by I1 represented as minus AI. So this minus of minus we can get plus. So HI RI is equal to HI plus HR AI into RL. This is also one of the equation for input impedance. Sometimes this equation only enough to calculate the input impedance. This is minus AI. So here there is another formula. We can also substitute that AI formula in terms of H parameters in the equation. You will get this below equation. So this equation is just by replacing this current gain formula HI is equal to minus HF by H naught plus H naught H 1 plus H naught into RL. So when we substitute this current formula, when we substitute this current formula equation, so HI plus HR minus HF divided by 1 plus H naught into RL into RL. So in this equation, we'll get minus term in the second term. And then, so in order to cancel it, this RL in the numerator, so take the RL term in the denominator. When we separate RL, H naught plus 1 by RL. This RL cancel. So we'll get H naught plus 1 by RL in the denominator. So that we will take Ri is equal to Hi and minus term he comes here. So we'll get minus term. So Hi minus HR HF divided by H naught plus 1 by RL. So this is also useful parameter, useful this input resistance or input impedance parameter to be calculated in the amplifier. This input resistance in represented in terms of HI, input impedance of transistor model minus reverse voltage gain multiplied by forward current gain divided by admittance, output admittance plus 1 by RL. This is the input resistance. Now voltage gain. Third parameter calculated from this amplifier, voltage gain. Gain is nothing but ratio of output by input. Voltage gain, voltage output by output voltage by input voltage. So here we have output voltage in common emitter configuration, common emitter amplifier. Output voltage divided by input voltage. So it is the ratio of output voltage nothing but V2 and it is under V1, V2 by V1. So we have formula for V2 minus I2 into RL. So minus I2 divided by V1. So when we take this equation, substitute the value of I2. What is I2? Current gain. So gain is equal to minus I2 by I1, or in small letters we can representation minus I2 by I1. So I2 is equal minus AI into I1. So when we consider this, I2 is equal to minus I1 into AI. So replace this I2. So we get this I2 is nothing but minus I1 AI. So minus of minus plus AB is equal to, replace this I2. So current gain multiplied by I1, AI I1 into RL divided by V1. So here the voltage gain formula in terms of current gain RL and the ratio of I1 by V1 is nothing but V1 by I1 nothing but RI and I1 by V1 nothing but 1 by RI. So it is very simple. It is linked with the previous parameter. So once we find out the current gain, that current gain formula used in input impedance, and the current gain and input impedance formula or input resistance formulas are used in voltage gain. So just take the voltage gain V2 by V1 and take the V2 formula minus I2 RL, and we have a I2 formula in terms of current gain minus I1 into AI. Current gain AI I1 RL divided by V1. so that we can replace this one is equal to RI. So voltage gain is nothing but current gain into small RL divided by input resistance RI. So here it is resistance units, so resistance units cancel, and current gain is no units and voltage gain is no units, so that you will get no units in the left side. So here AI current gain already we had, and RL and input resistance RI. So once we first calculated the AI and then RI, those parameters substitute in the AV and multiplied with the RL, so that you will get voltage gain. It is very simple to calculate. Already AI and RI are calculated, then you can just substitute in this AV. Next, output resistance. This is the output resistance. It is observed by setting the source voltage Vs to 0 and the load resistance to infinity. So in order to find out the output resistance in the transistor amplifier, by setting the source voltage Vs is equal to 0. Vs 0 means short circuit of the source resistance, source voltage. So this source voltage gets short circuited, and apply a voltage source at output side V2. Then we can measure the output resistance from looking into port 2. So it is obtained by setting the voltage source Vs to 0 and load resistance to infinity, and by driving the output terminals from generators V2. So what is the R0 is, it is defined by setting those conditions, by setting Vs 0, by setting RL infinity, and that open terminals connected with the source, which is represented with the V2. So it is the ratio of output voltage V2 by output current I2. So V2 divided by considering I2 equation, H parameter model equation, I2 is equal to HF I1 plus H0 V2. HF I1 plus H0 V2. The value of current may be obtained by applying Kirchhoff current law to the input side of the transistor amplifier. So by considering the input Kirchhoff voltage law, Kirchhoff current law. So the short circuit at input side and one RS resistance and port 1 start here. So here the transistor. So we can apply here. Then what is the value? First here it is RS. Here it is Vs is equal to 0. It is 0. And current flowing through the RS and internal parameter Hi and voltage source. So Hi and RS are in series, so the same current I1 passing through the source resistance and Hi, H parameter model resistance. So we can calculate this one, RS, Hi and voltage. So Vs is equal to 0, it is 0, and RS and Hi in series with I1. So I1 current flow in the loop. So I1 into RS plus Hi plus V, VR H2, HR V2. It is a voltage source. So that when we apply the Kirchhoff voltage law to the input side of the transistor amplifier, we can get RS plus Hi into I1 and HR V2 is equal to 0. From this equation, we can get what is the I1? So I1 is equal to minus HR V2 divided by RS plus Hi. What is the main purpose of this output resistance? Is that output voltage V2 by output current I2. So we have an input current here I1, and this input current is substituted in the I1 place, so that it is represented with the V2 RS V2, and then so when we substitute HR V2 divided by RS plus Hi in this equation, then the output resistance V2 I2 is equal to, in the numerator V2 term, in the denominator HF into minus HR V2 by RS plus Hi plus H0 V2. When we take the LCM, when we take this denominator term and multiplied by this numerator terms, then Rs plus Hi is this term is goes to numerator. So Rs plus Hi, and then in the denominator we'll get Rs H naught plus delta H plus delta H. This equation will get Hf Rs plus Hf Hi plus minus Hr V2 plus H naught V2. I'm sorry. So this one is minus Hf Hr V2 plus H naught V2 into Rs plus Hi. So here when we take the V2 terms and take the separate V2 terms and numerator V2 and denominator V2, we can cancel it. And then in the denominator we have a term H naught Rs, H naught Hi. So H naught Hi H naught minus Hf Hr plus H naught Rs. This is the first term in the denominator, and then this is delta H. So in the delta H we can calculate Hi, H11, H12, Hr, Hf and H naught in the matrix form. So determinant of this one is Hi and H naught minus Hr and Hf. This can be represented as delta H. So we can consider Rs into H naught delta H in the denominator. So final equation of this output resistance is nothing but, so R naught is equal to source resistance plus input impedance or input resistance divided by Rs plus Rs H naught plus delta H, so that we can calculate output resistance. So all these parameters, input impedance, current gain, voltage gain. First we need to calculate current gain. Once we calculate current gain, then we can calculate input impedance, so that the input impedance in terms of current gain, and then voltage gain, so that in terms of these two, and then output resistance R naught. So these four parameters are helpful to analyzing the particular amplifier. These are the formulas: R naught, AV, and then Ri, and then AI. These formulas are calculated or obtained from general transistor amplifier. But when we particularly consider that a transistor amplifier is in common emitter or common base or common collector amplifier, then just extra subscript added to the amplifier H parameter model. That will be seen. We'll see in the next lecture.
Like, share and subscribe. Hit the bell icon for more updates.